So in the previous class, I had given a homework about about the refractive index, which can be calculated through the prism, right? So that part I gave, and only so who has submitted. Yeah, Mariam has submitted that homework, and only Mariam has submitted that, right, Mariam? Yeah. So
Yes,
that,
sir.
yeah, that part I didn't do in the class, right? That part I have to do. So yeah, let me just do that part, and then yeah. So this result we got when we had this A, which was very small. So for a small refractive angle, for a small angle of prism, this will be the solution, right? But let's say we don't have a small angle of prism A. Then what would be the minimum deviation? So for that case, what would be the minimum deviation? So let us do that. All the results would be same, but we will apply these scenarios. So let me zoom out this one. And we will always use this condition. So this is the most general condition that we use. So what are the things that we know already? Yeah, what are the things that we know already? So recall. We know that A is R1 plus R2, right? And deviation is I plus E minus of R1 plus R2, which is E, right? These are the two results that we already, okay.
Yes.
And there is an important relation between the angle of deviation and the angle of incidence. So this is a very crucial graph that we have to remember. So relation between the angle of incidence and angle of deviation. And this is a graphical representation. So it behaves like a parabola. So this goes like this, right? And at this point, so this y-axis is what? This is deviation. This is angle of deviation. And x-axis is angle of incidence, right? So you guys can see that at this point, what is the angle of deviation? Because if I move left towards this one, and if I move right towards this one, all these values are, you tell me. So what about this position? What is the value of delta at this position? What can you guys tell? And let's say this is 30 degree, this is 20, 30, this is approximately 40, 50, 60, 70, and 80. So, what can you guys tell me about this point? What can you guys tell? Yes, Mariam, what can you tell me about that?
Left 40.
No, that is not, forget about this line, so this may be different. Figuratively, from this graph, what can you tell about angle of deviation? Angle of deviation is what? At this point.
0.
This is some angle of deviation, right? So at this point, angle of deviation is minimum, right? Angle of
Yes, sir.
deviation, because if you move in this direction, if your angle of incidence is, let's say, 30 degree, you are having some angle of deviation. If your angle of incidence is, let's say, 50 degree, you have some angle of deviation. But if you are at this point, let's say this is not, it is appearing to be 40, but let's say at this point, the angle of deviation is minimum, right? And at this point, so this is your angle of deviation minimum, right? And at minimum angle of deviation, your angle of incidence becomes angle of emergence. So this is the crucial information from this graph. We can see that this graph is parabolic, right? So at this point, this angle of incidence becomes angle of emergence, right? Is that clear,
Yes.
guys? So if my angle of incidence, right, if my angle of incidence is equal to, so this is normal, so this is my angle of emergent, this is my angle of incidence, right? So this angle is refracted angle, this is R1, and this is R2, right?
Yes, sir.
So you guys can see that this value, right? This value and this value, if this angle is same as this one, then this angle would be same, right?
Yes, sir.
So if angle of incidence is angle of emergent, then R1 would be equal to R. And let's say that is R. Okay. Is this point clear?
Yes, sir.
So now we can write all these relations. We can write what would be this, we can write what would be this, right? So at delta M, minimum angle of deviation, A is R plus R, right? Which is A is 2R, okay? So let's say R is A by 2, right? And your minimum angle of deviation, this is what? This is I plus I minus of A, right? So this is how much? So this is 2I minus A. So angle of incidence is how much? Angle of incidence is delta M plus A by 2. This is angle of incidence. Is this clear, guys?
Yes, sir.
So we have this angle of incidence, we have angle of refraction. Then remember, this angle of prism is not small. So if we apply Snell's law at this point, so Snell's law at this point, right? This is air, This is, let's say, some glass, right? So if I apply the Snell's law, what would be the Snell's law? Can you guys tell me from
N
here?
NGA.
Yes, from here. I'm going from here to here. So what would be Snell's law? N air into sin
N
I, right? N air
N
into
L
sin. Yeah, N air into sin I,
N
right?
glass into cyanide.
Equals, yeah, equal to N glass into sin I, right?
Yes, sir.
So let us write applying Snell's law. Applying Snell's law, what do we have? We have N air, and this is sin I. Now remember, this sin I is not small because angle of prism is larger, right? So sin I equals to N glass and then sine of R. So N air is 1, right? Sine I is sine I is how much? Sine of delta M. This is looking like same, right? So I should write it. So sine, and this is A plus delta M by,
Sir,
yes,
sir, why is N air 1?
because refractive index of air is how much? What is the refractive index of air? This would be velocity of light, and in the vacuum divided by velocity of light in air. So these are closely equal, right? Right. This is the refractive index,
Yes,
right?
sir.
So C by C would be 1. So N air is 1, right?
Yes,
So, so N glass, let us write that as N, and sine of R we have calculated, A by 2. So that is the relation that you have used, right, Maria, in your calculation. So N would be how much? Sine of A plus delta M by 2 divided by sine of A by 2. So remember, whenever you want to calculate the refractive index, we always use this relation, right? And remember, this prism is in the air. So if we put this prism in, let's say, water, right? Let's say if we put this prism in, let's say, water or some medium. Let us take an example of water. So then what would be the case? Then you have, this is water, this is angle of incidence, right? And this is angle of refraction. So now if you apply the Snell's law, so from Snell's law, this would be how much? Oh, who has joined now? Arsalan, so you are back.
Yes, sir.
So what would be Snell's law if I apply Snell's law at this surface? You have returned, so now you tell me what would be Snell's law.
So I just came back.
Yeah, this is angle of incidence. You are going from water to glass. So what would be the Snell's law? This we have done so many times.
So Snell's law will be
At this surface, what would be Snell's law? So
so so from water to glass, right?
yeah, yes, Mariam, yeah, the left part is correct. What have I told you about the Snell's law? Please revise, right? Let's say this is the, and this is, so this is angle of incidence, this is angle of R, this is refracting surface, right? This is N1 medium, this is N2 medium. So what did I tell about the Snell's law? N1 sine I, this is
is equal
N2 sine, this was
R.
the, this was the Snell's law, right?
Hmm.
So what would be Snell's law at this surface? These things are very trivial. We have to always remember these things. Hmm.
So from water to glass, right?
Yeah.
Uh,
So,
uh,
so first we write the refractive index of the first medium, wherever we are, right?
hmm.
So, where are we?
We're from water, and then
What?
we go to glass.
So
A
we will
sign.
write so n of water, right?
Hmm.
And then sin I equal to n of glass, and then sine of r. So this would be the Snell's law, right?
Okay, sir.
So if we again write these as whatever we have written in here, so n water is n water, we don't know how much is that, and sine of I, which is a plus delta m by 2, and this is n of glass, sine of a by 2, right? So then we will get the reflective index, let's say n of glass divided by n of water. This would be how much? So sine A plus delta m by 2 divided by sine of A by 2, right? So if this is what, if this is air, from air we are going, then this would be 1 and then we'll get this one. But if this is some medium in which we have kept the prism, so previously what did we see? Previously we saw that we were going from air to glass. Prism was in the air, right? Prism was kept in the air. So we got the refractive index of the glass, right? By calculating the angle of prism that we know and by calculating the minimum deviation. So this we can calculate from the experiment. From observation, we can calculate these things. So we can calculate the refractive index. But now if we have put this prism in water, then this would be the irradiation. So is this thing clear? Everyone, is this thing clear?
Yes, sir.
Okay, so Arsenal, you have joined late, so let me just tell you that what did we do. So earlier we saw that for a small angle A. So for a small angle A, we have reduced this to this one, right? This was our minimum deviation. But let's say the angle of prism is not so small. So prism is not thin. Prism, prism is not thin. There is a thick prism. So for thick prism, these were the results, right? And then from the relation of angle of incidence and angle of deviation, we got this relation, that this graph tells that what is this point? This is angle, y-axis is angle of deviation and x-axis is angle of incidence. So at this point, what is the angle of deviation? Epsilon.
Yes, sir.
What is
From
the
which?
angle of deviation? This is the graph. At this
Hmm.
point, what is the angle of deviation? Is it maximum? Is it minimum? Or what?
So at this point, the angular deviation is minimum because it's reaching the lowest point.
Okay, one. Yeah, angle of deviation is minimum. That is correct. So who got disconnected? Mariam got disconnected. So angle of deviation is minimum at this point. And you see that angle of incidence becomes equal to angle of prism. At minimum angle of deviation, your angle of incidence becomes angle of emergence, right? Because let's say at this point, this is your angle of incidence, but this would be the angle of emergent, right? At this point, this would be smaller. At this point, this would be smaller. And at this point, angle of incidence would become equal to angle of emergence, right? So this we got from this graph. At minimum angle of deviation, your angle of incidence becomes equal to angle of emergence. And then what did we see? That angle of incidence is equal to angle of emergent. Then this angle R1 would be equal to R2 because R1 is what? This is this is total 90. This total is 90 and 90 minus this E. That is your R2, right? So that is your R2 and similarly I is 90 minus R1. So both these R1 and R2 would be equal. If I equal to E, then R1 would be equal to R2. So then we reduced this result that we got earlier and we wrote this. We got this thing, angle of incidence, and then we got angle of reflection. And then we used the Snell's law, and then we got these results. So that was what we have done so far. Is this clear, Arsala?
Yes, sir.
Okay, where did Mariam go? So you guys please note it down. You guys please note it down from here, and then we will do two questions to understand this. Yeah, so Mariam has joined back. Mir has also joined. Yes, Mir, Assalamu alaikum.
Walaikum salam, sir. Sorry, sir.
No, no, no. Why? Sorry. So must be some work that you have to do. So that's why. Right. You didn't deliberately join it, right? So there
Yeah.
must. So let me again recap this thing, right? And one moment. Let me just text TikTok. Okay. Yeah. So what we have done, Mariam, we didn't go ahead. So we are just noting down whatever we have understood. So, Mir, you also note down from here, right? From here I have started. So you first note it down, then I will explain this thing again, right? This is angle of deviation, right? Yeah, whenever you guys have noted it down, please tell. So these results we got from the triangles portion, right? Using the properties of the triangles, these results we got. And using these results, we will see that how the refractive index is dependent upon the angle of minimum deviation and the angle of prism. So these two quantities are very important. From these, we can calculate the refractive index. So I had assigned a question previously about this thing. So that question we will do here.
Yes, sir, done.
Then, what about all of you guys, Mariam, Mir, and Aisha is traveling. Done? Oh, Aisha,
Yes, sir, done.
how are you noting it down, Aisha? But, okay, this part you guys also put it down. And this thing you can also understand from here, right? So if angle of I is equal to angle of E, so in here what is, let's say this is N1 and sine I equal to N2 sine of R1, right? So sine of R1 is how much? This is N1 by N2 sine of I. Similarly, from here, what is uh, what is the Snell's law? N2 sine of R2. This is equal to N1 sine of E. And we know that E is equal to I, right? So sine of R2 would be how much? That would be N1 by N. So if we compare this one and this one, so from here we can see that this angle is equal. Sine of R1 equal to sine of R2. So R1 would be equal to R2. We can also see from here and we can also see from this triangle also that this R1 would be equal to R2 if I is equal to. So these are the two things that we got for the minimum angle of deviation. For minimum angle of deviation, I equals to E, R1 equals to R2. And then we use these Snell's law. Yes, whenever you guys have noted it down, please tell. And we will do questions and then we will understand about the optical instruments.
Yes, sir. Done.
Done. Everyone noted. Then we down this. So this is what we generally use, right? This is the general form. Earlier we saw that n or delta m was n2 minus 1 into a. This is for the small angle. So this result we don't use. Generally, in most of the cases, we use this result. Enable focus. Okay, so yeah, whenever you guys have put it down, please tell. Yes, whenever you guys want me to scroll down, please tell.
Sir, can you please scroll down?
So everyone has
Sir. Yes, sir.
yes.
Done.
Okay, so then please move down. Yes, whenever you guys have noted it down, done everyone.
Yes, sir.
Okay, so now what was the homework that I gave, right? Yeah. So let us understand that question and we will recall that. Uh, yeah, so I will just write the question for you. Like, the second part is not. What was the homework that I gave in the previous class? So do you guys have the book, NCRT book with you? Do you guys have that book with you now? Aisha is traveling, so Aisha cannot have. Do you guys have the book with yourself right now?
No, sir.
No, so I will write that question for you guys. Yeah. So the question is, and this is NCRT exercise question 9.6. This was the homework that I gave, right? So it tells that a prism, what is that? Is made of. Oh, yeah, so a prism is made of glass of unknown reflective index. That is a prism. So which means that we have to find this unknown reflective index, right? Of unknown refractive index. Okay, then a parallel beam of light, a parallel beam of light is incident on the face of the prism, right? The angle of minimum deviation, the angle of minimum deviation, let me write it as this. So this is measured to be how much? 40 degrees, right? What is the refractive index of the glass prism, right? When yeah, so the the refracting angle of the prism is 60 degrees. So what is this 60 degree? What is this 60 degree? Yes, guys, please tell me. If the prism is placed uh, in water, in water, and its refractive index is 1.33, predict the new this one. Okay, so this is the question. Did you guys understand this problem? Yes, did you guys understand this problem? So what are the things which are given? Let us calculate the first part. In the first part, we have to calculate this unknown refractive index. This is part one, right? Second part of the question is this one. So this is second part. So first, let us find out the refractive index of the glass prism, right? How can we know that? So what are the prior information that we have?
Delta
Prior,
M.
yeah. So prior information is we have delta M, which is 40 degree. What is this refractive angle of the prism? What is this thing? This is angle of prism, right?
Yes, sir.
And you guys can see that this is not so small. So we cannot use the simplified thing. So we have this thing and we have this thing. And we know that this prism is kept in the air. So another prior information that we have is the refractive index. This is sine of A plus delta M by 2 divided by sine of A by 2. This is the thing that we know. In air, this is this, right, everyone?
Yes.
So let us, we have this delta M, we have this A. Then we can easily calculate this refractive index, which is 1. So let us do the first part, right? Unknown refractive index. And, and this is how much? N is sine of A plus delta M by 2 divided by sine of A by 2. So sine A plus delta M, this is how much? Sine A is 60 and delta M is 40. Oh, should take a simple value, right? We should take or we can just find out what is this value. And divided by sine of 60 by 2, right? So this is sine 100 by 2 and sine of 30 degree. So sine 30 value we know, right? And sine 50 is how much? Sine 50 degree divided by sine 30 is 1 by 2, right? So this is 2 into sine of 50. How much is that? We just use the scientific calculator. So yeah, so sine of 50. This is 0.76. Let me check. It is 60. This is 0.766. So into this is 1.532. So this is the unknown refractive index. So Mayam had solved this problem. And what did you get, Maya? Let me check. Yeah,
0.53, sir.
1.53. Good. So
Yeah.
that was the correct answer. Now we have to calculate. So now in the second part, we have to calculate what is the new delta M, right? When we place this prism in water, so we already know that for the second case, in water, what is the reflectivity? So N21 is sine of A plus this is the new delta M, right? Divided by 2 and sine of A by 2, right? So N21 would be N2 divided by N1, and this is sine of A is 60 plus delta M prime by 2 divided by sine of 30. So that would be how much? So N2 into sine 30 divided by N1 is sine of 60 plus delta M by 2. So N2 is, we have calculated, that is glass 1.53, 2 divide into 1 by 2 and divided by, this was given, right? This was 1.3. So 1.32. And this is sine of 60 plus delta M divided by 2. So this is this is how much? So 1.532 into 0.5 divided by 1.32 equal divided by so this is 0.576 and sine of 60 plus delta M by 2. So if I want to calculate this delta M, what should I do? If I want to calculate this delta M, so what should I do, guys? How can I simplify this thing further? What would be that? Yes, if I want to find out this delta M, new minimum deviation, so how can I calculate this thing? I have to take this sign in the other side. That is how I simplify, right? So if I take this sign in this side, what would be that? Yes, Mariam, Arsalan, and me. What would be this?
Yes, sir.
Yes, what would if I take this sign in the left hand side? What would be this?
0.576 by sine.
No, no, no. This is not multiplication. This is sine inverse, right? This is inverse function. So if I have, let's say, y is equal to f of x, function of x, and I want to take this function in the left hand side, so this would be f inverse y and this would be x. So similarly, this is sine function. If I take it in the left hand side, so this would be sine inverse, right? So you guys
Yes,
have,
sir.
yeah, you guys have mathematics, right? Or okay, so if you guys don't have mathematics, just understand that this is sine function. If I take in the other side, then this would be inverse function, right? So how much is this value? Do I have that calculated? Oh, I don't have sine. Okay, how much is this sine inverse? Let me check this value. This is 0.61 radian. Radian, which is how much? So pi radian is 180 degree. So 180 degree, 1 radian is 180 by 5. So 180 by 5.
Sir,
Yes.
sir, can you please explain how to get sine inverse?
Yeah, so I googled this value, right? They will simple values. So let's say if you want to calculate, yeah, let me just explain this. So let's say they will say that what is sine inverse 1 by 2, right? So this result, for what value of sine you get half. What is the value of theta? For that you get half. So theta is sine inverse half. So what is the theta for which sine value is half? Did you understand this part?
Yes,
So what is the value of theta for which sine value is half? How much is that?
30.
30 degree, right? So theta would be 30 degree. So either if you get, and let's say you are getting something like sine inverse root 3 by 2, right? So this you can tell that this would be 60 degree. So either if you get these kind of values, then you can directly calculate. But let's say if you are getting this value, so either you can write this in this manner, or they will give you this value. So in the question paper, they will give you that sine inverse of this value is this much. Okay. Or you can keep this answer like this one. So what did I get? 0.614 radian. I will keep this. So you can simply write this delta m prime as 2 into sine inverse 0.576 minus of 60. So this answer is complete. Okay, this answer is complete, but if you simplify this thing, so how much would be that? This is 0.614 radian is 180 by 5. So this is 0.614 into 180 by 3.1. How much is that? 180 into 0.614 divided by 0.1. So 35, right? Okay, why am I getting 35 degree? And then you multiply this with this 2. So this is 30.19, right? This is 35.19 degree. So if you put that value in here, so in degree, how much would be that? 35.19 minus 60. So you will get 10.38. So this would be the new minimum deviation. Okay. So either you can write this value, you can stop here, or if the value is given, right? If the value of sine inverse this thing is given, then you can put that value and then you can get the result. So is this question clear to everyone? Is this question clear to everyone? What did we calculate? Yeah, in the first part, the prism was kept in the air and we calculated this refractive index. Unknown refractive index we calculated. And in the second part, the prism was kept in water, right? So then we used this thing, and because if we are putting this prism in water, then your minimum deviation angle will change. So this would be the new minimum angle of deviation, and we have to find out this thing. So we just put all those values, and then we got this value. So this was the homework, and this was the question from NCRT 9.6. Is this clear, everyone?
Yes, sir.
Okay, so you guys please note it down, and if you have any doubt, please ask. Right? Please ask me if you guys have any doubt. So, Mariam, how did you do this problem? Yeah, so you also calculated NGS 1.53 you got. Oh, but why didn't you write the value of sine 50 and sine 30? You directly wrote the answer, right, Maya?
Yes, sir.
Yeah, and again, why have you written this is root, this is delta m, right? Did you write root m? Is this root?
No, sir, that's delta M.
Oh, so delta is written like this d, and you write d as this one. So s you can write, and then from s you write d. So this is delta, right? And this is delta. So you have written like this. This is
Yes,
appearing.
sir. Actually, my school teacher writes it like that.
This is root m, right?
Yes, sir.
Please write it like this, right? In NCRT, you will see that they have written it like this, right? Okay, so this was Mir and Arsalan. Is this question clear?
Yes, sir.
So we will do one more problem that I have chosen, and then this idea would be very clear. So only we have to remember that refractive index is this. If the prism is in air, and if prism is not in air in some medium, then refractive index would be n to 1. Simply that. So that is the only thing that we have to remember. Okay, so what was the question that I had? Yeah, whenever you guys want me to scroll down, please tell. So this was the direct problem, right? We just put the value of delta m at a, and then we got this unknown reflectivity. Yes, whenever you guys have noted it down, please,
Yes, just scroll down.
I had to start this optical instrument, but I guess so. Sine 50 degrees is 0.7. Remember n to 1, right? So we are going from n1, which is water, and n2, this is glass, right? N2 is then which we have calculated. N2 we have calculated, and n1 is given.
Yes, just scroll down.
Okay. So what did we got? Sine inverse of not this was 0.614 radian. So I changed this radian to degree. And how did I change that? I multiplied this radian by 180 by 5. So then this answer, this is radian and this would be in degree. That is what I have done. So whenever you guys have noted it down, and if you guys have any question, please ask.
Yes, sir, done.
Done. Me and Mariam, what about you? Aisha, how are you noting it down if you are traveling?
One
You are
second, sir.
okay. You are maybe you are taking a screenshot, right?
Done, sir.
So the next question is kind of a similar question, and that would be easy to understand, right? So you guys already know about the complementary. So complementary angles, right? So what is sine 90 minus theta? How much is this? Yes. This is cos theta, right? Similarly, cos of 90 minus theta, this is sine theta. So these are complementary angles, right? So let's say if I want to calculate sine of, let's say 35. So I can write this sine of 35 as sine of 90 minus, I can write this 35 as 90 minus how much? 55, right? 90 minus 55 is 35. So this would be how much? Sine 90 minus theta. So this would be how much, guys?
Say cos
Cos how much?
uh, 35.
What is theta in here? 90 minus theta. Theta is how much?
55.
55. So see, sine 35
Oh,
would be cos 55. And you can see
Sir,
this.
can you explain again?
Yeah. So how can you write in terms of 90? How can you write this 35? How can you write this 35? So I can write 35 as 90 minus 55. Is that correct?
Yes, sir.
So I have this sine of 35. So I can write this 35 as 90 minus 55, right? And whatever is sine 90 minus theta, that is your cos of theta. So is this clear?
Yes, sir.
So, so you guys can also understand from this relation, sine of 30. So I can write this sine of 30 as 90 minus how much?
60.
60. So sine 90 minus 60 would be how much?
Cos 60.
Cos 60. And you guys already know the value. Sine 30 is how much? And you also
1
know
by 2.
that, so sine 30 is cos 60, right? So these are called the complementary angles. Okay, clear, everyone.
Yes, sir.
Okay, so we will use this thing in our question. So the question is that, what is the question? The refracting, and remember this is in air. So refracting angle of a prism is A, and the refractive index of the material, whatever the glass is of the prism is cot A by 2, right? Then the angle of minimum deviation is how much? So what are the informations that that are given? What is given, Arsalan? What
so the
are,
uh,
yeah? Yes, yes, you can tell me.
yes, sir. The refracting angle of prism is A,
Yeah.
and
So
so the refractive index of the material is given
yeah. So
of the
A
material
is
of the
given,
prism.
right? A is given, which is A. So this is absurd. A is A. And second thing, what is given? N is
So,
given.
hmm,
N is cot A by 2, right?
yes, sir.
And what else do we know? We know that N is sine of A plus delta M by 2 and sine of A by 2. This thing, these are the three things we know, right? And what is the question? What we need to find out? We have to find out this thing, right, guys? So idea is
Yes,
that
sir.
we put all these values in their respective places. So if we put that using the third relation. So n is how much? Cot a by 2. This is sine a plus delta m by 2, and this is sine a by 2. Right? And how much is cos theta? Cot theta is how much? This is cos theta by sine theta, right? Because everything is sine in sine, so we can write this in cos. Is this thing you already know, right? Tan theta is sine theta by cos theta, and cot theta is reciprocal of that. So if we put that value in here, so this would be how much, Jasola? This would be how much? Hmm.
Sir,
Using this one. So how much? So cot is cos by sine.
yes, sir.
So
Mm-hmm.
so cos
Call.
a by 2 sine a by 2. Correct.
Yes, sir.
So a plus delta m by 2 divided by sine a by 2. So these will cancel out. Right?
Yes, sir. So cos C by 2 is equal to sine A plus 8m by
Yeah.
2.
So cos a by 2, and this is sine a plus delta m by 2. So you see that in the right hand side we have a function of sine, in the left hand side we have a function of cos. But I already know the relation between cos and sine. So how can I write cos in terms of sine? How can I write that? Yes, cos in terms of sine. Can we use this one? Cos in terms of sine we can write, right? Is this clear?
Yes, sir.
So what would be cos a by 2? Everyone, please tell me. What would be cos a by 2 in terms of sine? How much would be this? How can I get cos theta from sine something? I will write below the result that we know. This is sine of something something. Yes, we have cos.
Sine something minus a by 2.
So 90 minus something is 90, right? 90 minus theta. Sine 90 minus theta is cos theta, right?
Yes, sir.
So 90 minus a by 2. Is this clear, guys? So sine 90 minus a by 2, this is theta, that would be cos a by 2. Clear? So I can write in here sine of 90 minus a by 2. This is sine of a plus delta m by 2. Now this we can cancel because both are same functions, so we can cancel. And this would be 90 minus a by 2 equal to a by 2 plus delta m by 2. Right? So this would be how much? 90 minus a by 2 minus a by 2. This is delta m by 2. So this is a by 2 is a, right? So this is delta m by 2. So delta m is how much? 290 minus a, which is 180 minus 2. So this would be the answer. Is it clear, everyone? Is
Yes,
it okay? So you guys please note down this problem. If you guys have any doubts, please ask. Please ask me if you guys have any doubts. Otherwise, please take down. Okay, I wanted to start this optical instruments, but I guess that would be possible in the future. So in next class, we'll try to complete this chapter because these two questions were very important and they may be asked in 5 marks question. That is why I have done. Yeah, whenever you guys want me to slow down, please. Again, you guys have this class assessment. So after this class, when it's over, please. Oh, you don't have any class. Because ray optics. Ray optics. We are doing ray optics. Yeah.
sir, it's showing it's not there.
Yeah. Because ray optics, I have not made some question in ray optics. That part. And
Just scroll down.
this thing is very important. Prism relation, the refractive index, relation between refractive index and minimum angle of deviation and angle of prism, which is reflective angle. So these relations are very important. Whenever you guys have noted it down, please tell me. Yes, assalamu alaikum, Rifa. So exactly at the right time you have joined. We are just finishing now.
Hello.
Yes, Rifa. Yeah, you are audible.
Yes, sir. Done.
Yeah. Okay, so see you guys in the next class, right? tomorrow we will meet again, and not tomorrow, day after, and then I'll start this optical instruments, right? So, what is the first optical instrument that you guys have naturally? From birth, you guys have that optical instrument. What is that?
Simple microscope.
From birth, you have simple microscope
Sorry, glasses.
glasses. From birth, that is naturally in you.
Lens.
Oh, lens. Your
What is
eyes.
eyes? Right, you have eyes, right? So yeah, you have eyes, and how do you see some objects? How do you magnify the objects?
Through lens in our eyes.
So yeah, so we just look closely, right? And the minimum distance that we can look clearly the object is the near point. So and we have the eye lens, which is the converging lens, right? Convex lens. So naturally we have a lens which is converging. Naturally, we have a magnifying lens. And in the next class, we will talk about the man-made lens that we use to just magnify it more, right? So you guys have seen those detective glasses, and from those detective glasses, we can magnify the objects more because we have some certain limits to magnify the objects, and those limits we can overcome using different kinds of optical instruments, which are man. I will talk about those in the next class. Okay. So bye guys, Allah Hafiz, and see you guys in the next class.
Love is
Thank you.
Allah Hafiz, Allah Hafiz. Okay, yes, Ripa. So in the previous class, what were we doing?